So we finished up surface area of cylinders. Now we're going to focus on surface area of cones. And first we got to talk about lateral area. That means the area that's not the area of the base, okay? So the lateral surfaces are surfaces that aren't the bases of a shape. And the base is the circle, and the lateral surface is the curved surface that goes up to that point. All right, you can see the net of this cone. A net is just a two-dimensional representation of a three-dimensional figure. We can fold and wrap this shape, this net, into this three-dimensional cone. Okay, and we usually use nets to kind of give us a better understanding of surface area. So there's plenty of resources and videos online of where this formula comes from. There's actually an activity in the book that you can use to do it. But we won't go there. We're just going to focus on using the formula appropriately. All right. So the formula for lateral surface area is just pi times the radius times this cursive L. And it's cursive for a specific reason. It's cursive to indicate a certain dimension on this cone. And the cursive L represents slant height. That's different than the height of the actual cone, which goes straight through the center of the cone. Slant height is on the outer edge, from the outer edge of the base up to the apex or the vertex of this cone. So it's this outer length here. All right, so that's different than I guess your regular L, but it's talking about slant height. So here is an example of how to find the slant height. How to find the lateral area. Just use that formula, pi RL. You see the radius here and the slant height here. Now, some diabolical math teachers might label this inner height as well with some number, and then you'll have to be like, wait, I don't need that dimension. It's extra information that I don't need to use. And you ignore that and just use this outer slant height and this radius to find the lateral area. Okay, practice here if you'd like to see if you can get these two answers. If you feel like you're really confident that you can just use this formula, plug in two numbers and get an answer, then skip those for now. All right, I'm going to turn these off so you don't get a heads up later in the problems when I actually want you to try them. All right, here we have this key concept of surface area of a cone. All right, it's basically just the lateral area, that curved surface, plus the area of the base, which is a circle, so it's going to be pi r squared. So if you're taking notes, which I hope you are, then I'd like you to indicate this formula here as something to pay attention to, something to write down on a reference sheet, or something to identify on the reference sheet that I posted on Google Classroom. All right, so surface area of a cone is right here. Let's use that now on some examples. Okay, here's just another drawing of a cone and its net. All right, and here's an example of using that formula. So we have, this is the lateral surface area, and this is the area of the base. And we can see how we just replace the R with the radius of the shape, which is 6. And we replace the L with the slant height, which is going up the side there, 6.2. Plus pi and the radius squared. So just plug them in, calculate, and boom, you got it. Try this one on your own, pause, and then check my work against your work and see if you got it. Okay, pause it.
I found something.
Oh, that's my little girl, Alethea. You found something. What'd you find, honey?
I found this.
Pi r L plus pi r squared is my formula. I am going to substitute in the radius for, this is C, by the way. I got it. The radius there is 4.5. The slant height is 20. And we're going to add to it pi times the radius squared, which is going to be 4.5 times 4.5. Whew, all right, let's see if I can calculate all this. So we have pi times 4.5 times 20, and we're going to add to it, that's right, pi r squared. So that's going to be pi times 4.5 times 4.5. And we're rounding to the nearest tenth here. Yes, we are. So that's going to equal 346.36, which rounds to 0.4. So 346.4. 346.4. And let's check. What are we doing? Area. So that's going to be millimeters to the second power because it's a two-dimensional measurement. There we go. Got it. Perfect. All right, let's check it out. Now, this is just giving you an example of when of that, just to show you that reading the directions is going to be important because sometimes it'll save you from extra work. Anyway, if we read it, it says, gives us the dimensions of the TP, and then it says to find the lateral area only. So then we just use this formula and not the full surface area formula. All right, let's read this, got it, and see each hat has diameter, slant height. Okay, so find the lateral area of one hat. If it told you to find the surface area of a hat, you would actually have to know that it's just asking for the lateral area because a hat wouldn't have a base, right? It would have a hole where your head would go. So you would just be finding that curved surface of the cone and not so this kind of lets you off the hook and you don't have to realize it, but the lateral area is already indicated up here that you're finding that and not the whole area of the cone. Okay, so here's the answer. Try it yourself. See if you get this answer. Boom. Hope you did. And we should be closing up this lesson. Pretty simple. If you'd like to practice these ones on your own, go for it. Here are the answers. Check yourself and see if you can get those. That's just, now read the directions. It's just finding the lateral area. All right, and then here is an example of two where you can find the actual full surface area. See if how you're doing by showing the work and trying those ones if you'd like, if you feel like you need some extra practice. All right, hopefully that was pretty quick and simple. Good luck.